Okay, typical problem of the partial fraction decomposition. I copy the expression inside the integrand function. I try to do the partial fraction decomposition. Okay. This expression is irreducible quadratic. Then the top part is ax plus b. This part is real, but it's repeated. As you see, it's repeated. So you take this and another, decreasing the exponent. Okay? This is the typical format. Okay, now the complicated part, not complicated, you know, long part, is determine the coefficient A, B, C. We can do using Wolfram alpha, or we can do using the calculator, no? The graphic calculator. Okay, let me try. Be careful with the parentheses. Open parentheses, I copy the original. X squared minus 29 x plus 5. And close the parenthesis to indicate this is the top part, divided by, open two parentheses, inside the first parenthesis, in the bottom is x minus 4, square, wait a second, square, time, parenthesis, x square plus 3. Close the parenthesis and close another parenthesis, que este parenthesis que enclose everything in the bottom. Let me see if it's good or not. I don't know. Okay, we compare this and this. Perfect. Now partial fraction decomposition is in this calculator is algebra F2, option 3 expand. You put inside the function, press enter. There you go. Okay, so the answer is A is -1. This is -1. B is 2. C is -5. And D is +1. Let me check it just in case. -1, 2, +1, and -5. Perfect. Super. Now let's copy. Let's copy. The problem is we have 1, 2, 3, 4 integral. Now the first integral is -x dx over x squared plus 3. Que is that part. This is substitution. I define u like x squared plus 3 du is 2x dx, sorry, multiplication by 2 and divided by 2. We have 1 minus -1/2 integral du over u, okay, is -1/2 natural logarithm absolute value of u, and u is x squared plus 3. Okay, but this is my first answer of that part. The answer is -1/2 natural logarithm absolute value x squared plus 3. And we continue working. We continue. Okay, we continue. We continue. Okay, the second integral is integral 2 dx over x squared plus 3, que está apart. Well, this is super easy. This is 2, well, 2 is a constant. Entonces this is radical 3 tangent inverse of x over radical 3. I, of course, using one formula. Well, you can do using trigonometry substitution, no? Pero hello. Suppose you memorize this formula as perfect. Suppose integral dx over x squared plus a squared x equal 1 over a tangent inverse of x over a. This is the formula. Can you memorize that formula? I solve this. I have the second part is 2 radical 3 tangent inverse of x over radical 3. Okay. Well, I erase that part. Erase and erase. Let me see. Yeah. No. Okay. The rest is pretty easy. The rest is integral negative 5 dx over x minus 4 raised to the second power. But in this case, substitution again. X minus 4, sorry, equal u, dx equal du. This is negative 5, is a constant, du over u squared. It's a negative 5, integral u to minus 2 du, therefore it's negative 5, u to the minus 1 divided by negative 1, negative is positive, so 5 over u, but u is x minus 4. So we continue the answer then. The answer is plus plus 5 over x minus 4. Now the last one. The last one. X minus 4. The last one is integral dx over x minus 4. This is pretty easy. This is natural logarithm of absolute value. X minus 4 plus natural logarithm of absolute value x minus 4 plus the arbitrary constant. And this is the final answer.